All right. So, working on through chapter 2. This is the midpoint of chapter 2. Uh, so, we've been working with conditionals, converses, and then biconditionals. We're going to continue with that and go just a little bit further with those. So, consider the following conditional statement. If the converse is true, combine the statements as a biconditional. Where our conditional is, if 3 points are collinear, then they lie in the same plane. Same line. Well, if we flip that around, if 3 points are on the same line, then they are collinear. Yeah, both of those are true. So we can write the biconditional. 3 points are collinear if and only if they lie on the same line. Now, we're going to get started talking about deductive reasoning. It's also called logical reasoning, so it's the process of reasoning logically from the given statements to a conclusion. So, if the hypothesis is true, deductive reasoning would produce a true conclusion. So, it's like going through, okay, if it's cold outside, I'm going to wear a coat. If I wear a coat, I'm going to stay warm. And it's just kind of going down the line like that. So, you're starting with one thing. That's true, well, that means this. Well, if that's true, that means this. If that's true, that means this. And we just keep on going. So, like, for example, a mechanic begins work on a car and discovers that the battery is dead. What conclusion could be made? Well, if the battery's dead, you can conclude the car's not going to start. So, that would be your deductive reasoning. Hey, this happened. Well, since that happened, that means this. Now, if we go the other way, if the mechanic starts working on a car and discovers it won't start, will you conclude it's the battery? Well, it might be one thing. Maybe it's the starter. Maybe it's out of gas. There's other things that you can go, oh, it's not starting, then it could be this. But if you know the battery's dead, then you know for sure, yeah, it's not going to start. So, key there is you have to know that the hypothesis part is true. Then you can say that the conclusion would be true. So from there we can get into, we have a property called the law of detachment. So that's what I was talking about, is if the hypothesis is true, then the conclusion will be true. So for any if P then Q statement, if we know the hypothesis is true, then we know that the conclusion is true. Well, let's do an example of that. So, for the true statements, what can you conclude? Well, we're given that if M is the midpoint of a segment, then divide the segment into two congruent segments. We also know that M is the midpoint of AB. So we look, okay, so we have the if then here of if it's a midpoint, then it's divided into two congruent segments. Well, it's saying M is the midpoint. So it's saying, hey, this hypothesis is true. So we would say, by the law of detachment, we conclude that M divides AB into two congruent segments, or that AM is congruent to MB. So because this was true, the conclusion is true, that it divides it into two congruent segments. Divides it into two congruent segments. Yep. Now, we have to be careful with this. Does the following argument illustrate the law of detachment? So if it is snowing, then the temperature is less than or equal to 32 degrees. The temperature is 20 degrees Fahrenheit. So we conclude it must be snowing. Does that work? Well, this ties to the then. That's the conclusion. This does not work. Because just because it's 20 degrees doesn't mean it's going to snow. It just might be cold. However, if it's snowing, then it has to be cold. You don't see it snowing in the middle of July. It has to be cold for it to snow. So if we would say, hey, it's snowing, then we could conclude that it's less than 32. We can't say, hey, it's less than 32 and know that, hey, it's going to snow. So with this second statement has to go with the if part, not the then part. If it goes with the then, it doesn't work. Has to go with the if for the then to work. The other part of this is law of syllogism. And I don't know if I'm pronouncing that right. English people can probably correct me on this, but that's how I'm going to say it. So law of syllogism. If P implies Q and if Q implies R are true statements, then P implies R is a true statement. So think of this as the transitive property of statements. So if P, then Q, and if Q, then P, we can just jump straight from if P, then R. Or, yeah, if P, then Q, then if Q, then R. So just jump from P to R. So we have if a number is prime, then it does not have a repeated factor. If a number does not have repeated factors, then it is not a perfect square. Can we use law of syllogism here? You betcha. Key thing here is we have to have a then matching up with an if. So then it doesn't have repeated factors, if it doesn't have repeated factors. What ties together? Cross it out. So they both share the repeated factors statement. So we get rid of those, and what's left is our law of syllogism, is that if a number is prime, then it does not have then it is not a perfect square. So what repeats, cross out, and what's left is your new statement for your law of syllogism. Now we can put these together and use both. So we're going to use both law of detachment and the law of syllogism to draw a conclusion about the following. So when it comes to your homework, when you have a problem like this, you're going to need two answers. First, your law of detachment, and then your law of syllogism. You have to put both of them together. Have two answers there. So we have, if a river is more than 4,000 miles long, then it is longer than the Amazon. If a river is longer than the Amazon, then it's the longest river in the world. Actually, I said that backwards. Do your law of syllogism first, then do your law of detachment. Well, what overlaps here? Well, what overlaps is that it's longer than the Amazon. So then it's longer than the Amazon, and if a river is longer than the Amazon. So what's left then is that the Nile is, or the law of syllogism would say that if a river is longer than 4,000 miles, then it's the longest river in the world. So if a river is more than 4,000 miles long, then it's the longest river in the world. Law of syllogism. So you'd have something like this. Law of syllogism, this is what we get. Well, then we have this statement that the Nile is 4,132 meters long. Ties into the if, the hypothesis, so we can conclude with law of detachment that the Nile is the longest river in the world. So, both things, law of detachment, law of syllogism. So go through, get rid of the overlap, come up with your conditional then with law of syllogism. Based off of what it says then, use law of detachment to conclude the conclusion there then. And that's it. That's this lesson. So, questions, comments, concerns, let me know. You can always pan me, email me, send me a message on Google Classroom. Otherwise, until next time, we'll talk to you later.